Alright boys, so the number 2 fishing crimp sleeves, it turns out I have to cut them in half down the middle in order to have the, the top set of pulleys and the bottom set of pulleys for forward direction and reverse direction of the motor be separate systems that can move freely, independently, and then I have to have the ability to pull all slack out of both lines because there's going to be some speed differences during the rotations of the motor because of the different gear ratios and stuff of the two sides. They need to be independent and they both need to be tensioned independently. So I'm now cutting these fishing crimp sleeves in half using this miter saw thing. You can see it's got a little cutting wheel right here, right there, and it's got a little vise. But we couldn't put the crimp sleeves into here. It's not designed for something that small, so we had to create actual. I had to drill this out with a little drill by hand. This is the tip of an X-Acto knife, and now we're using that as a clamping tool, kind of like what lathes use, so that the fishing crimp sleeve is like this. And then we were able to grasp the whole X-Acto knife into this vise here. I'm just eyeing all the measurements, using my left eye just to kind of guesstimate. So I can always file it down to size after the fact. I just want to get most of the metal close to the halfway point. Okay. Show you guys the setup. So that's how that looks. I found a previous fishing crimp sleeve I had cut and lost. Just found it on my shirt. There it is. Maybe that's when I chopped off. Anyways, to get it out of here then I have to take it apart and use an X-Acto knife blade to slide it out of the slot. So this is some really microscopic work and a bit of a pain, but necessary. But yeah, I didn't fully understand or realize until today. I had a feeling there'd be some speed issues that could cause some problems. And my initial instinct was to put the top and bottom pulley systems on separate little crimp sleeves, rotating independently of each other. They shouldn't be trying to be all connected. That was a mistake. That was just an oversight. So I'm glad I caught it now before I did any more with getting all that wound up and stuff, because it all has to be redone now since it was um, not going to work. So I'm glad I caught it kind of early. And here's how one of them I got done already looks. You can hardly tell that it's two fishing crimp sleeves. There it goes. You might be able to see the parting line. It's subtly visible. You can see a little glimmer where they're split in the middle. And they both fully independently will move too. They move freely. So they can spin different directions, different speeds, and that won't be a problem at all. So we have to mount one extra plastic disc. So it's going to be one on the tip, one on the other tip, one on this tip, one on this tip, and then one in the middle. So each one will have 3 discs on it, making for a total of 6 discs between the two of them. And I have to cut out all the discs again, I believe, as well, because the ones that are on the system with the fishing crimp sleeve that's still joined and it hasn't been cut in half, I found that I wasn't able to cut in half with the discs on it. The discs were just overheating and losing their stick and just coming off and getting ruined. And they're covered in super glue, so if I were to rip them off and then try to re-glue them, the glue wouldn't be grabbing everything optimally. I think it's just better to start over on that part, so I will have to recut out all of them, which is a bit of a pain, but if you think about it, we're catching this early, so this is just the first motor. We have to do at least this on 30 motors if it all works out according to plan. So having to redo one motor out of 30 is not that big of a deal. I'm just hoping that we can perfect it and not have to keep redoing things over and over and over. So that's the one little tweak, is decoupling the two systems. That way any speed differences occurring won't cause like a bunch of slack to be created between the different tacks. There will be slack created, but we can pull out that slack on the side that's not being actuated, the side that's just kind of on brake. That side will have a bunch of slack generated, and we can put that slack on a spring where, like, if you picture a straight line, if you put a little hoop if you have like a tube and then a straight line in between it, you could put a little eyelet and then pull the eyelet off to one side in order to pull that string out of straightness and pull it taut, if that makes sense. I'll actually draw that because this is pretty critical. So you'd have like Teflon, TPFE guidance tube, TPFE guidance tube, and then your string going through it like that. Okay, but what if this string is loose and we just want to always keep it under tension? You could have the string take a turn here and then come out to here and then come to here. And this would be going through an eyelet, and then the spring would be here, a tension spring. So this way the tension spring pulls this eyelet to the left, which pulls this string, all the slack out of it. But then when this string gets pulled by the motor from this direction, this eyelet would become a straight line. This would straighten itself out, and this tension spring would give way, allowing the thing to become a straight line across from tube to tube again. But when the motor is not actively working on this particular set of string, then the tension spring will win the fight and pull all the slack out of the line. That way, the pulley system will always be kept under tension for both directions of the motor when the string that's not in use, that's not being actuated, would otherwise be possibly getting a lot of slack that's not getting pulled out, which would cause the pulleys to loosen up and then cause tangling and spaghettiing and stuff like that. Spaghetti noodles, like just a mess. So this will keep it all taut and tight, even though they're going to be moving at different speeds. This will solve that. This is in the run out phase. This can be done like on the forearm or whatever, anywhere, to always keep both strings under tension fully and get rid of all slack. So technically this is our slack line, but it's kept under tension. So it's tensioned slack available at any time, and it's created and uncreated on an as-needed basis. So I hope that sheds some light on the solution to the speed differentials question.